Okay, good morning, class. Okay, you haven't done question number 3, right? Okay, now solve the question number 3 before we proceed to the power method. Okay, so for question number 3, matrix C, find for the eigenvalues. Diagonal entries minus lambda. Find for the determinant and let it be 0.
Eigenvalues.
We find for the determinant. Yeah. Okay, all the diagonal entries minus lambda. Okay, so 1 minus lambda, -1 is 0. -1, 2 minus lambda. -1, 0, -1 and 1 minus lambda. And let it be 0. Okay, so this one I use shorthand. Okay, 1 minus lambda, where 2 minus lambda, Okay, then 0, 0. Okay, minus another direction, 0. This one is plus. Right? Even bigger. Bracket plus 1 minus lambda. This one plus 1 minus lambda plus 1 lambda. Is this what you get? Okay, so we fine, right? 1 minus lambda square, 2 minus lambda minus, this is 2 set of 1 minus lambda, right? This is one set, this is another set, so we have 2 sets. So here we can factorize. Okay, factorize this 1 minus lambda, so you have another 1 minus lambda here, and 2 minus lambda. So here, after you factorize, you have minus 2. Okay. Then here, this one, you expand, simplify, factorize for this part. Okay, so when you factorize, you get 2 minus lambda minus 2 lambda plus lambda square minus 2. Okay, so it means 1 minus lambda lambda square minus 3 lambda equals to 0. Okay. So factorize the lambda, right? Factorize the lambda. So we have 1 minus lambda minus 3. Okay, then we get the 3 eigenvalues. Okay, and I will follow this sequence. I follow this sequence 3, 1, 0. Lambda 1 is 3, lambda 2 is 1, lambda 3. Lambda 3 is 0. The next, starting from the first eigenvalue, we find the eigenvector. Substitute the lambda into the one that you find for the determinant, the A minus lambda I. Your lambda, the sequence of this eigenvalue, it doesn't matter. It can be lambda 1, lambda 2, lambda 3, lambda 1, lambda 2, lambda 3, doesn't matter. Because later on, your answer will be in one pair. This is one pair, one pair, one pair. So start from lambda 1. Lambda 1 is 3. So you substitute lambda by 3. Form the matrix. And then right hand side all 0. 1 minus 3, negative 2. Negative 2, negative 1, 0. Negative 1, 2 minus 3. Negative 1, negative 1. Okay, 0, negative 1. 1 minus 3 is negative 2. Then we draw reviews. Draw reviews. We just need one operation, okay, one operation to change the negative 1 to 0. So the operation is what is the M? Negative 1 over 2, R1 plus R2. Okay, so negative 2, negative 1, 0. So 0. 1 over 2 minus 1, negative 1 over 2. Negative 1, 0. And then 0, negative 1, negative 2, 0. Then one more operation. What is the operation? Huh? Negative 2. Negative 2, R2 plus R3. Okay, negative 2, negative 1, 0. 0, negative 0.5, negative 1, 0, 0, 0, 0, 0, 0. Okay. So what's next? What's next? You have to identify which variable is free. So you sketch this. So which one is free?
One. This one.
Huh?
Two. S3.
Simply this one, x2, x3. Which one?
S3.
X3. You have to know which one is pivot. Okay, you have to know which one is pivot. So we let x3 be C. C is a real number. Yep. Okay, up to this, does any one of you do not know how to identify which variable is free? You all clear with how to identify which variable is free?
In the air.
Huh? The one without the pivot. One row has only one pivot. Okay, one row has only one pivot. X3 has no pivot. That's why X3 is free. Okay, and how do we know that it's a pivot? That pivot must stay right on the line, the horizontal line. At the first row, this is the only one that sits on this. This is the pivot. And here, these two sit on this horizontal line. So either one. Normally we choose the first one to be the pivot. Okay, so if this is the pivot, that's it. This is not a pivot. X3 has no pivot. X2 has a pivot. X1 has a pivot. X3 has no pivot. So X3 is free. Okay, then we apply backward substitution. Okay, negative 0.5 x2 minus x3 equals to 0, and your x3 is C. So that's why 0.5 x2 is negative C.
Yeah. Lima pala pera.
So two is negative 2c. Okay, negative 2c. Okay, then from the first row, negative 2x1 minus x2 equals to 0. Okay, we want to find for x1, so 2x1 equals to negative x2. Negative x2. Okay, so x1 is c. So for your answer, x1, x2, okay, we just write v1. Okay, v1 is x1, x2, x3. Factorize 1, negative 2, 1, where c is the real number. So do we need to normalize this? We need to normalize this because this magnitude is more than 1. Right? This is more than 1. Okay. So by taking c equals to 1, so your v1 will be, okay, when this is 1, you have 1, negative 2, 1, and we want to divide all entries by negative 2, because negative 2 has the largest magnitude. Okay, so this means you have negative 0.5, 1, negative 0.5. Okay, so this is your V1. Any questions? Okay, no, continue to the second answer. Please. Okay, whoever signed for your attendance. It's 1. Repeat the process by substituting lambda by 1. Depends. If this is this one, I think it was last year or last 2 years, it come up in the midterm. Midterm normally midterm normally 2 questions. Each question has 2 parts. This one normally 1 question. So according to that past year midterm, it will be around 10 over 20 marks. Your midterm covers 20 marks, right? Okay, but for this semester, I'm not sure. I'm not sure yet which topics is coming up in the midterm.
Yeah. We need to set
we need to substitute lambda into the A minus lambda I just now. We have the A minus lambda determinant, right?
Yeah.
Okay, lambda 2 is 1. So you substitute the 1 into the lambda just now. So 1 minus 1. Negative 1, 0. Negative 1, 2 minus 1, 1. Negative 1, 0. Negative 1, and 1 minus 1, 0. Okay. Okay, so this one we have to row reduce. Okay, we have to row reduce. So what is the first step? We have to swap first row and a second row. First row and second row. Negative 1, 1, negative 1. 0, negative 1, 0, 0, 0, negative 1, 0, 0.
Yeah, that's what.
Okay, you have to swap because this pivot position could be a non-zero. Non-zero entry. And since you have a non-zero entries underneath, so we swap. Okay. When you sketch for the staircase, okay, there's a non-zero there. Okay, you have to go down, turn right. Then you know this is a pivot. You have to change this into 0. So what is the operation? Negative 1 and negative 2. Negative 1 are yes. Negative 1, 1, negative 1, 0, 0, negative 1, 0, 0, and all 0. Okay, that's backward substitution. Okay, but before that, you have to identify which one is free. X3 is free. X2 has a pivot. X1 has a pivot. Okay, this one we can't choose this as a pivot. This is 0. Pivot must be a non-zero. Okay, so in between these two, this must be the pivot. Okay, this must be the higher. Normally we choose the first one. Okay. Okay, so x3 is 3.
X3.
So we let x3 is c. Then backward substitution. X2 is 0. X2 is F. Negative X2 is 0, so X2 is 0. Then the first row, okay, first row you have negative X1 plus X2 minus X3. And we want X1. So X1 is X2 minus X3. X2 minus X3, which is negative C. Negative C. Okay, for your V2, okay, your V2 is X1, X2, X3. Okay, then we have to let the C be 1. Okay. So when C is 1, we don't have to divide all the entries by anything because this is what we want. The largest magnitude is 1. Okay, so this is our this is B2, I'm sorry. B2. Okay, last item value, lambda 3. Okay. Any questions for lambda B2?
Not yet.
Okay. And we look at lambda 3. Lambda 3 is 0. So you have 1, negative 1, 0. Negative 1, 2, negative 1, 0, negative 1, 1. Okay, row reviews. Okay, X3 is 3. X3 is 3. Backwards substitution.
Đây, bạn đang đi bạn tadi. Ada jam ni mah. Lepas dapat janji. Ya. Semalam aku jadi juga penting. Kalau dapat jadi nak kena saya nak kena simplify terasa tempat. Isa. Sampai siap. Daging film. Pak Edilek.
Now to power method. Okay, we still have 1 hour plus for the power method.
Kalau kita tarik
Okay. Can we proceed to the next? Power method. Okay, power method. Okay, now look at the screen. Okay, power method with scaling. Okay, we will scale the eigenvalue. Sorry, we will scale the eigenvector for each of the iterations. Okay, so now let lambda 1 up to lambda n be the eigenvalues of n by n matrix A. Okay, we know that given a 3 by 3 matrix, we have lambda 1, lambda 2, lambda 3. If you have a 4 by 4 matrix, we have lambda 1, lambda 3, lambda 2, lambda 3, and lambda 4. Okay. And lambda 1 here, okay, for power method, lambda 1, okay, is the dominant one. Okay, is the dominant one. Strictly dominant. Okay. Lambda 1 must be strictly dominant. Strictly dominant means it must be the largest. Okay, it must be the largest one. For example, okay, this one. If you have 3, 2, and 2, this is the first example. Lambda 1 is 3, lambda 2 and 3 is 2. Okay, so this is your lambda 1. And for the second example, if you have -5, 2, and 1, -5 is your lambda 1. Okay, because this one, it has the largest magnitude. This is the dominant eigenvalue. Okay, strictly means no equal. You see your lambda 1, okay, lambda 1, the magnitude must be greater than the rest. Okay, must be greater than the rest. Okay, and the eigenvector that corresponding to this lambda 1 is called dominant eigenvector. Okay, so this is dominant, lambda 1 is dominant eigenvalue, and the corresponding B1 will be dominant eigenvector. So this is what we will find from the power method. It will provide only your lambda 1 and B1. Okay, we won't find for lambda 2, lambda 3. We will just get the lambda 1 and B1. Okay, we look at first example. Apply the power method to this matrix with, okay, this is the starting. We need a starting because for numerical methods, we will always need a starting point or either starting point, starting interval, starting vector. Okay, this one we need a starting vector, B0. Okay, so estimate the dominant eigenvalue and the corresponding eigenvector of A accurate to within this epsilon 0.0002. Okay, numerical methods, U will be given an epsilon. If epsilon is not given, that means epsilon equals to 0. Okay, if it is not given, that means epsilon is 0. Okay, so these are the steps. Step 1, we will find for the AVK. Okay, AVK. The iteration will start from 0. Okay, iteration starts from 0. So when K is 0, we have AV0. Okay, this one, AV0. So A is the matrix A, V0 is the starting factor. Okay, so here you have to know how to find, how to compute for the multiplication. So this one, okay, always the raw followed by column. Okay, raw column, that means 6 times 0 plus 5 times 1, then you get 5. Okay, then second row with the column, you get this 2. Okay, once you get this, okay, AVK, we will identify which entry is the has the largest magnitude. Okay, the largest magnitude or the highest absolute value. Okay, so 5 is the one. Okay, 5 is the largest one. So your M0, okay, M0 is 5. Okay, M0 is 5. Then we will compute for the next B. Okay, next B. This is something like the normalization actually. Okay, so the 5,2 that you obtain from here, the AV0 5,2, we will normalize this by dividing all the entries by 5. So that's why you have this 1/5, 5,2. Okay, your next B is 1/5, 5,2. So 5, 5, you get 1. 2 times 0.5, 0.2, you get 0.4. Okay, so this is your next V. Okay, once you get your next V, compute again for AK. Okay, compute again for AK. This one later. We compute again for the AVK. So AV1, then V2, AV2, V3, AV3, V4, and so on. That's the process. And how do we know when to stop? We will find for the error. Okay, this is the infinity norm. Okay, infinity norm. We will use the latest V minus the previous V. Okay, the latest one is this one. V1 is this. The previous V0 is 0, 1. So this one minus this one minus this, you get this. And the infinity norm means out of all these entries, we will select the magnitude, the largest magnitude. The magnitude is 1. The magnitude is 0.6. So the largest one is 1. So that's why the error is 1. Okay. So from here, okay, once you get your V2, then we will check for the error to see whether we can stop the iteration. So this one, V2, this is your V2 minus the V1. Okay, your V1 is here. So 1 minus 1, 0. 0.225 minus 0.4, you get negative 0.175. Okay, so in between 0 and negative 0.175, the largest magnitude is 0.175. Okay, but this is still greater than, what is the epsilon just now? 0.0002. Okay, epsilon is 0.0002. So this is still larger than that. So we compute for AV2. Okay, AV2, this is, okay, just now I missed one, your M. Okay, this M actually is similar to the scaling. Okay, the way that we divide the vector, actually, this is the scaling. Okay, scaling normalize here. This is normalization here. Similar. Okay, here we call this as scaling. Okay, because we want the AVK to have the largest magnitude 1. Okay, we want the AVK to have the largest magnitude of 1, and that will be your next V. Okay, so this one, the largest one, the entry with the largest magnitude is 8. If this is negative 8, okay, if this is negative 8, this will be negative 8. Okay, because this is entry. Okay, this is entry. This is error. Error is different. Error, we just look at magnitude. So that's why error, it will always take the, we don't take the negative. Okay, for error, we don't take negative. Okay, but for M, this is entry. If there's a negative here, we will take the negative together. Okay, so AV2, after you compute, the largest one, the largest entry is this one. So this is your N2. Okay, so this one divided by this, okay, to get your next V. Okay, to get a next V. Then use the V3, this is your V3 minus the V2. Okay, then you select the largest magnitude to be your error. Okay, so continue the process. This one is still greater than 0.0002. So we continue. Okay, this is greater than 0.0002 up to this point. Okay, this is less than 0.0002. Okay, so we can stop the iteration here. Okay, we can stop the iteration here. And your eigenvector. Okay, your eigenvector will be this one, the last V. Okay, the last V is your dominant eigenvector. And your eigenvalues given by M. Okay, given by M. But this is V6, right? The sixth iteration. This is only 5. So to get the M6, that means we have to compute for AV6, right? So we compute the AV6 and get the M6. Okay, that's why your dominant eigenvalue is M6, 7. And your dominant eigenvector is V6. Okay, I repeat one more time. Okay, when you see the error is less than the given epsilon, then we stop the iteration. Okay, we stop the iteration, then the last V will be your dominant eigenvector. this is your dominant eigenvector V6. And your dominant eigenvalue is M6. Because they comes in a pair. You cannot say M5 and V6. It must be M6 and V6. How to get M6? We have to compute AV6 to get an M6. That's why even though here you can stop the iteration, but to get the dominant eigenvalues, we still have to compute for AV6. AV6 to get the M6. Okay, M6, V6. Okay, so this is the dominant eigenvalue, dominant eigenvector. Okay, now we look at another example. Okay, this is similar. Okay, similar. Given a matrix A, the starting vector is 1, 1. Okay, the given epsilon is 0.001. Okay, so AV0, identify the entries with the largest magnitude. Then do the scaling to get V1. Okay, to get V1, you just divide all this by M. Then this is your V1. Check for the error. Okay, then compute AV1. AV1, identify the entry with the largest magnitude, which is this one. Okay, this is your M1. Okay, next, to get V2, okay, use this divided by this. That will be your V2. Check for the error until the error is less than 0.002. Then 0.002. That's mean this one. This is less than 0.002. Okay, is it? Sorry, 0.001. Okay, the given epsilon is 0.001. So this is still greater than the epsilon. So we need to compute for one more iteration. I can check for check again for the error. Okay, this is less than the epsilon. Okay, then V7 will be your dominant eigenvector. Okay, V7. So your dominant eigenvalue will be M7. Okay, your M7, you haven't got your M7. That's why you need to compute for AV7 to obtain your M7, the dominant eigenvalue. Okay, clear? Okay, we try this. Okay, so we will compute for AV0. We compute for AV0.
Until when?
Okay, A, -1, -6, 0, 270, 1, 2, -1. Okay, and then V0 is all 1. Okay, then get the value. Use all decimal places because it doesn't state the how many decimal places, so we use 4. Okay, so draw first, draw column. This one times this plus this one times this plus this one times this, you get the first one.
Itu juga scenario betul lah.
Benar tu. Itu kecil scenario.
Sampai tadi lambat deh kayak cebet.
Seven. I two. Yes. So what is your M? Nine. Okay. Then you have to compute for V1. Yes. To get V1, you just normalize this. Just normalize this. That's been 1/9, -7, 9, and 2, right?
Yes.
So you get the -0.378. Okay. 1. Yeah. 0.2, right? 2.
Benar.
Okay. Then next error V1 minus V0. Okay. The infinity norm V1 minus V0. This one minus 1. This one, this is your V1, right? V1 minus V0. V1 minus V0. So this one minus 1, you get no need to this one. 1.378. This one minus 1, right?
Yes.
1 minus 1, 0. If this one minus 1,
Wait.
1.22.
0.778.
okay. So the infinity norm of this is 1.7778. Out of these three, this has the largest magnitude. So we just put the magnitude here. Okay, we just put the magnitude as the error. And then next AB1. Okay, AB1. Okay, B1 is this one. Repeat this once again. We start from A, B, K. Iteration is always start from 0. We always start from 0. So A, B naught. So this is the given A. This is the given B naught. So row, column, get this. Second row, column, you get this. And the third row, column, you get this. Okay. And from here, we have to choose the N3 with the largest magnitude. Okay. N3 with the largest magnitude. So this is this one has the largest magnitude. So if there is a minus here, then you have to take the minus here. Okay, if there is a minus there. Okay, then V1. V1, we just normalize this. We normalize this vector. Okay, normalize this vector means that we divide this by this one. Okay, then you get V1. Then for the error, use the latest V1 minus the previous V0. Okay, so then you get this. This one minus one, you get this. This one minus one, you get this. This one minus one, you get this. When you get the factor, we find for the infinity norm. Infinity norm means the largest magnitude from the entry. Okay, the largest magnitude from the entries. This will always be positive. Positive because we just show the magnitude. It's different from here. This is not error. This is not error. So when there's a negative, we have to take the negative. But this is error. Infinity norm, we are finding for error. Error, it will always be positive. We just take the magnitude. Okay. Since this is not less than 0.005, so we have to continue to the next iteration, AV1. Okay, so A, this is your V1. Compute, identify your M1. Okay, keep repeating this until your error is less than 0.005. As given in the question. I show solution on the screen. Okay, so this is the first iteration. So have you done the second iteration?
Yeah.
Yes. Check your figures. Okay, then proceed to AV2. Not yet.
Betul. Ya, jadi juga poin untuk sama. Yung point ito sa naman tinapos. Itu bukan kurang. Jadi kita dapat ini. Soal lain apa itu sebenarnya?
And then the next equation.
Yeah. Itu pun kalau itu lagi itu sampai ke pendidikan. Oh, pendekatan oke udah. Bisa tengah awal yang hanyut. Oh ini. Siap gini. Nanti kita kosong poin dan kosong minggu. Jauh ini. Jauh lagi. Apa?
Any questions?
No. You can you will go something about that. Gimana soal pengalaman?
Okay, show again the previous iteration. Okay, for those who haven't started AB2. Okay, this one, all got the answers?
Yes.
Yeah.
Okay, so AB2 and AB3.
Itu berarti tentang itu ya. Tadi buat jadi gue ini pasal poin 8393. Benar?
Secret faster man. Faster man. What's slow man? Faster man. Competition man. Pasal poin 8393. Còn lại là ủa cái như ya lu itu sembilan euro pounds bukan ada sembilan tadi dia kan bisa dulu dalam kalau yang kedua itu dari sudah ikut dari itu apa tidak betul Aduh, satu lagi betul. Poin double 05 kan? Yang tadi maximum minimum kan? 0.05 kan? Sekali. Satu lagi. Ini 5.00
Okay, done this. No. Okay, AB4. What is that? So just now? 0 point?
0.005.
0.005. That means this is less than 0.005.
Ada yang tertinggal, kalau tertinggal M dia belum lagi. M dia paling cepat, nak kena buat M 105. MV3 dia cepat.
Okay. When the interval is less than the given epsilon, then that means you have found the dominant eigenvector, which is B5. Okay, B5. Dominant eigenvector is B5. So your dominant eigenvalue will be M5. Okay, M5. But you have M4 only. So to get M5, you need to proceed to one more AV5 to get the M5.
Cuba tengok, cuba back. Tak back boleh? Back, boleh. Ke belakang. Tolong boleh back. Sampai lagi besar. Alright? Sampai lagi besar ini kecil ni. Actually dah turun. Yang mana ini kecil. Tak apa yang kau nak find the answer. Ya. Biar faham tadi paling besar kan antara tiga yang tolak sah. Ini kosong point lagi besar daripada ni. Yang orang pengen nampak nilai di sana. Ada kisah yang ada itu. Dalam kita juga itu orang juga dapat nilai tes 0.04 yang jadi ketika kalau kita masuk di ruangan dia pun bisa ini bawah
Okay, but now you're still working halfway, you can snapshot so that you can do your own Excel checking of this first two iteration. Okay, and the next two iteration. Wait.
Dari I'm
Okay, done. Okay, the last. Okay, done. Okay, if you manage to get the right answer for at least two iterations, then I think you know how to compute for this one. It's just that until the last iteration, when you see that your error is less than the given epsilon, you need to compute one more ABK to get the largest, to get the dominant eigenvalue. The last V will be your eigenvector. Okay, the one when you see that this error is less than the given epsilon, the V will be the dominant eigenvector. Okay, dominant eigenvector V5. So the corresponding eigenvalue will be M5. Okay, M5. So that's why you need to carry out this ABK, AB5 to get M5. Okay, once you get V5, use V5 minus the previous one. Once you get V3, that's V3 minus V2. How to get this one? Okay, V5, this one, sorry, this is your V5, this is your V4. Okay, so this one minus this one minus this, and this one minus this. Can you see which one has the largest magnitude? Yes, the largest magnitude, the largest difference. Okay, the largest difference. But we just take the magnitude. So no error, no negative for error. No negative for error. Okay, any more questions?
No.
Not yet. Not yet. Okay, so this is our method. Okay, so we have done the syllabus for week 4. Okay, we have done the syllabus for week 4. Okay, so please select your groups. Please select your groups for your section and also your assignment group. Okay, assignment group. Section 2. Section 2, the space you choose from group 1 to group 13. Okay, you can start to decide. Okay, who are your group members?
Jumpa. Tahu sebelah pulau lah. Pulau lah.
So when I go through the feedback from the last week, okay,
Attention, please attention.
I think mostly is LU. This one. We teach how to do Newton Raphson. Is it from this section? Is it from this section too?
Who do this? Who do this? Reason. We teach how to do Newton.
Question on Newton Raphson. Does any one of you want me to repeat the Newton Raphson from this section?
We need section 1. Oh, section 1, section 1. Sebab section 1 kan online.
Oh, yeah.
Section 2 tak pernah online lagi. Kena online lagi. Ya. Terus juga
Example in tutorial. Okay, for tutorial question, if you think that tutorial question is not enough for you, you can go to the library. Okay, go to the library, find any books of this. If that is under numerical methods, find a numerical methods book. If that is under the calculus, okay, differentiation, integration, find a book under calculus. Okay, you can get a lot of excitement.
in the book.
Oh yeah, I forgot. Later I follow up with the author. It's okay.
It's okay, it's okay.
It's okay. Okay, understand. No, this one. Wait, two. Rewinds back LU decomposition. Okay, I think tomorrow I will have a meeting with Dalton Foster, the committee member of the Maths Tutoring Center. I think maybe some of the specific topics will be discussed in the MTC. Okay, MTC, the Maths Tutoring Center. That means the selected students will join the MTC, but students who are free and want to join, you are welcome. Okay, we haven't set the schedule. Okay, we will give a schedule when is the MTC open and students can come. Okay, with the math questions. Okay. Okay, and we will have one math competency test, mathematics competency test. Okay, that test does not carry any marks for your assessment. for this one. That one is just we want to see what is the level of students before EM1 and after EM1 on the basic of maths. I just want to see what is the standard for students before EM1 and then after EM1. Okay, is it matched with the grade of EM1? Okay, that one normally we will run online. Okay, that one just run online. Okay, so I will update in the group for that one. Okay. Okay. Since we still have around 30 minutes, okay.
Okay, it's okay.
What do you want to do now?
Review.
You want to review any subtopics?
Tutorial number 9, chapter 1.
Tutorial 1 or tutorial 2?
Tutorial 1, number 9.
Invest.
Inverse. Inverse of 2 by 2 matrix.
Then try tutorial 1, number 9.
Yeah,
Aku dah malas.
Okay, 2 by 2 matrix. You can have a matrix A, B, C, D. Okay, matrix A. So we need to find for the determinant. Okay, and the A inverse will be 1 over the determinant. Then here, these two we swap the A. These two we change the sign. This is the inverse.
Okay.
This is the inverse for 2 by 2.
Nanti baik sentuh macam tu. Nanti baik
Tutorial 1 or 2?
Tutorial 1, number 9. Kan? Tutorial 1, number 9.
1.
I tried many times. Yes, that one.
Okay, this one, does any one of you did or done this? You get the answer? Okay, so you just can you share the answer in the group so that students who can't get the solution can do the checking, because this involves a lot of calculation. It involves a lot of calculation, but this one, this one I roughly give the explanation of how to get the answer. Okay, for this number 9, okay, verify and join AB. So meaning that you have to find the A times B first. You get the AB matrix AB. Then from the output of AB, let's say C is AB, and let's say the matrix C is A times B. So the matrix C you need to find for the adjoint. Okay, then you will get one answer. Okay. Okay, then on the other hand, you find the adjoint of A and B respectively, separately. Then use the adjoint B, okay, the matrix of adjoint B, multiply to the adjoint A. Okay, you have to follow the sequence. Huh? Adjoint B, matrix of this, multiply to the matrix of this. Then you will see that the output is the same as this. Okay, this is how we get the answer.
Sorry.
Agresi aja orang tu. Aku jangan duduk jawapan.
Okay, this one, this is adjoint A. Okay, adjoint B, and how about the adjoint A and adjoint B?
Okay, nombor baru. Siapa sih?
Already said, right? Adjoint A and adjoint B. Okay.
Arvin dah punya nombor kita aja Arvin. Aduh, Arvin tu WhatsApp ni.
You get the same one, right? Yes. Okay, so you can check. I think you didn't get the answer, maybe due to some mistakes in the calculation. Okay, then anything else? Yes, one question. One question. Inverse matrix.
How
30 minutes. Okay, 30 minutes.
Okay. A minute. I'm very excited.
Okay. Any other questions? Okay, any other questions?
For so far so good. Project.
Any other specific questions on certain topics?
Nothing.
Okay. If no, then we end our session here.
Oh no.
Kau semalam banyak nak sakit?
Saya subjek lah tulis tangan dia.
Kata dia nak ini question. Dia tanya.
Ini membayar.
Okay, so I will see you next week. Next week, we will look at the complex number. Okay, complex number.